So, how was your lunch? You're ready? Okay, so for the first talk of this, you know, the problem with this stuff is that as soon as all the talk starts, you get a lot of noise only in one ear, and meanwhile you have to talk with a lot of people, and it's a mess. But okay, for the first talk of this afternoon, we have Rob Collins, who will talk again about test-driven development. So here it goes. Thank you.
Thank you. Well, good to see you all here. We're going to have an interactive session this afternoon. So I'd like to start with a show of hands. So hands up, who thinks that testing is a good idea? Write your tests before you write the code they're testing. All right, now keep your hands up if you always write tests before you write the code they're testing. And lastly, anyone who only writes tests, never writes code because you have to perfect the tests. Yes. Well, I believe in testing, and I'm going to present some themes about testing. Just let's close that bit noisy out there. Right, I'm going to present some themes about testing, and instead of questions at the end, I'm going to get you discussing both sides of the argument. So let's start with looking at what test-driven development means for me. You know, I find that by doing test-driven development, I'm able to sleep at night. I can go home from work thinking my code is working. It's either working 100%, all the tests pass, or it's working 99%, and there's a bug that I haven't yet written a test for, and it oscillates between the two, but you don't get the feeling that suddenly your code is all breaking and it's a mess. It reduces stress, it helps communication amongst the team, and delivers in the agile process what the customer wants quickly. However, you know, not everyone agrees with this this approach to testing. So what I have on my business card is test first and embrace change. So you're encouraging customers to change their minds as they go along. And it's important that they have that sort of flexibility, that you want the test there because it means you can change quickly and know if you've broken something straight away. If you haven't got something tested, you end up coding at possibly half the speed because you have to tread on eggshells because it's so difficult to know if you've broken something. This contrasts with the waterfall testing approach, which is test last. You know, the traditional idea, you have the design phase and the coding phase and the testing phase if there is time, and you control change. You control change by saying it's important that we don't allow the customer to make change requests for which they are not charged. That's how it used to be, whereas now we're saying, please customer, change your mind as you want. We can do anything. We have tests in place that mean that we're flexible and it's a powerful sell to the customer. Let's take the example of building a bridge. You've got a big task to be done, and the bridge, you know, it has to meet in the middle. There's an overall design task. You don't want bridges that sort of were great, built both sides, but they're about 10 meters out when they get to the middle. But all the components in the bridge must meet their specification. Every component has to rely on its encompassing components, that it really does work as it is meant to work. And the little pieces all working together make the whole bridge beautiful. That's the point of the unit testing in the detail, enables the functional testing in the whole. So I'd like just to explain about the history of how I came to find, first of all, I did testing at the end. Then I did testing where I was doing agile development and thought, well, I'll write my code and I'll write my tests. And I was writing the test afterwards. But finally, I got to the point where I was coding after I'd written the tests. I thought, really, this is a great... sorry, just... buonasera, Brillo. Guarda, è un po' imbarazzante. Sono nel bel mezzo di una presentazione ad EuroPython. Più mica aspettare? Ok. Ciao. Sorry. Please don't go away. I'll be back in a few minutes. I'm sorry.
Yeah, but it's fine. All of them. Just
Grazie a Dio ci siamo liberati di quel perditempo. Devo dirvi la verità riguardo quello che stava dicendo. I need to tell you the truth about what he's been saying. My name is Irma, and I've got about 15 minutes, I think, and I'll try to cover some of the time-wasting arguments. I believe in testing. Testing is good. Functional testing, that is. Does it do what the customer wanted? You know, the functional tests pass, you get a happy customer. We like testing, we like happy customers. But let me contrast waterfall development. We go through requirement, specification, code, testing and release. And that wasn't a bad way to organize things. Time scale, 1 year. Now, I can contrast agile development with that. Basically, the same approach, but you've got a time scale of 2 weeks. What matters is the speed. You're just doing the same things faster round and round. So your cycle, instead of it being a year's cycle, is a 2-week cycle. That's fine. It's about speed. And we actually like the speed combined with the big design up front. The point about the big design up front is that it precisely enables you to charge customers, to be able to keep charging them, to find out what they want, and it's not what they said they wanted, so you build what they said they wanted, and then you charge them some more when they discover it isn't what they wanted, but they asked you to build it, so they've got to pay for it. And in this process, we keep the testers out of the loop. They're there to ensure that the code we write matches what the customer said they wanted, and they're rightly a valuable part of a different department. We want to keep them in the QA department. Now, just thinking about Rob's bridge analogy. Well, you go to a play. Do you watch the play or do you deconstruct it? you know, what matters is the overall effect. You know, what was the point the author was making about the play? You go there to laugh and not to criticise the detail. You think about people who have to study plays, study the literature and find out what's the meaning of Act 2, Scene 3, Line 5. It ruins the play. You go into this sort of deconstructed detail. What matters is the overall picture, which is what the functional tests are there for. So let's compare a driving test. You know, there's a nice functional test. Can you drive the car? Now, the way they test whether you can drive a car and the way you're trained to drive a car is you get in the car and you drive it. That isn't that obvious if you think of the analogy with computing, because what they don't do is to have individual simulators testing different parts of your driving ability. So, I mean, we could take the example of a Miss Jones where the examiner ends up saying, "Great, Miss Jones, the way you turned left is really good. You've been practicing, obviously. And I've not ever seen such a skillful gear change at 90 miles an hour. You really must have pushed the gear change simulator. But I have to ask, Miss Jones, how much time have you spent driving a real car?" So, let's look at interviewing developers. A good functional testing process. We can want to see, can a developer do a good job? We want to test the whole of their ability. Now, it's a little bit tricky with this agile development stuff. You know, you can't really say to somebody, well, you can turn up for an interview anytime between 8:15 and 10:30. But you can ask them to stand up for part of the interview where you all stand up, and we know that, you know, if you're doing agile development, when you stand up occasionally to have meetings. An important part, of course, of my approach to this testing is it's about job protection. So you have to remember, when you're in an interview, in a situation, as you're the expert, what you want to do is to find some testing questions that test esoteric knowledge of Python that is absolutely no use to anybody when they're actually doing the job, but it makes you look good to the other people doing the interview and secures your job. And also, you can even extend this sort of functional testing to be a really good way of problem solving cheaply. You interview 10 different people and you give them a little exercise to do, and 10 different solutions. You could well have a product and you haven't had to pay anything for it. So, what's the problem with unit testing? Well, unit testing slows us down. The more tests, the fewer features. You know, same amount of code to write a feature as to write a test. So obviously, if you write tests, you only develop half as many features, and customers buy features. They don't buy tests. What matters is the number of features you've got, not the number of bugs. I mean, look at the example of Microsoft Word, and that explains it. You know, every feature, that's what people wanted to buy. So we don't want to double the workload. In fact, our objective would be to be able to say, with the integration tests, have fewer of them, have one large integration test. You know, you could have one test that tests everything from beginning to end, just does it do the job, one test done, I can go home. Now, these guys in Python Pro, what does it mean when they say they're developing the world's best appointment scheduling system? What does that mean? More features? Does it mean fewer bugs? Well, the best system, by definition, is the one with the most customers. So what you want is, you know, worse is better. That's been a theme of this conference. Do it wrong quickly. Let's get things out to the market, and testing just slows that all down. You know, we've got a commercial reason to stop listening to this hype about testing. testing ruins relationships. For staff and for customers, you think about the problems with animal testing. Unnecessary, inflicting pain on defenseless creatures. And it's the same with software testing. Developers need to fight back. Just when someone says, you've got to write a test, say, there is a moral objection to what you're asking me to do. And it misses out the most important point, that customers are our most important testers. That customer interaction is valuable. We've heard the importance of a good support program, that customers are more likely to buy from you again if they discovered a bug and you fixed it than if there was no bug, because there's been the interaction. Every conversation with the customer is a chance to upsell. No bugs, no contact. So customers like bugs. And there they are being asked to come in and test and remove these very nice features of bugs. So unit testing ruins job security. Apart from in the interview situation, you're trying to impress colleagues, you're wanting to keep your job, and you don't want people to know quite what you're doing. So when you write documentation, just make sure it isn't actually any use. And don't write unit tests, because if someone's got a unit test, they know how your functional method works. Now, if you've just got a functional test overall, testing something as a black box, only you know how the bits inside it work, then you have a key marketing point when it comes to keeping you in your post. So, can we rely on testing? Well, not testing avoids finding the false positives. In your code, you've got some horse meat, I expect, and do you really want to find it? Well, let's face it, most of your code is never going to get executed anyway. There's an ideal path for the code, and fraud isn't caught by testing, that people know what the tests are doing and they get around it. The example of the Microsoft Flight Simulator. In the old days, when you had to demonstrate that your computer, the manufacturer was making it PC compatible, a test was, would it run Microsoft Flight Simulator? So the people manufacturing computers thought, we will put in various hacks into our system that is not PC compatible just to run Microsoft Flight Simulator, so you can demo it in the shop, people get it home and find it doesn't actually work. So testing can be fraudulent. So let's think ahead. Let's write code that can't be unit tested. And this is quite simple to do. You just write it in large blocks of highly coupled code, so that when you try and test any one part of it, you can't really avoid bringing in the whole of the rest of your program. And then, effectively, you've got a functional test, which is your objective. And don't make the classes easy to mock out. So a good way to do this is, aim at sort of 500 to 1,000 lines in each class, and then nobody will try to do unit testing or mocking. A bit of thinking ahead there. So, let's look at some code tips. So what we want is some neat ways to get home early without breaking the build. So supposing you have one of the worst sorts of errors, it's an intermittent exception that only causes a problem one time in 10, but it's there and you can't work out why. Well, thing to do, we have the try except exception. Notice you don't actually specify which type of exception, just handle all sorts of exception. And you have something in there, the exhaustively handle all failing exceptions nice function that looks to the casual peer code reviewer as if you're doing something useful. You're not actually, because it just calls a pass, but you bury that in a deep utility library that nobody's actually going to look at because they presume that is all tested. And then your tests work, your code works, and you can go home. Now, Anders Hammerfist did a good bit of coding for me. I asked him for a bit of help with a function that does a bit more when you've got a problem of one of your tests is failing. So this piece of code manipulates the execution framework to enable you to take a series of tests and surreptitiously skip to the end, to the last line of your series of tests without anybody realizing it. So first of all, we have to count the number of lines that you have in your function. And then we can handle the event for the trace function. That means that it moves the line number in the frame to the last line. Effectively, it's a little go-to. So here we have a skip to end function. So we set the ftrace there, and that means that when we call this function, we will go from wherever we are to the end, to the last line. And so here we go. I've got a partly failing test, and there's a problem with line 4 of my method. And it's 4:30. I know if I submit the code as it is, I'm going to break the build. The screen will go red, and I'll be there for the whole evening. I'm going out, so I've got to make it pass. And there's the solution. The skip to end function, I just call it something like check build statistics that nobody would recognize as anything surreptitious. And you just add a little return or a pass or something at the end of the method, and there we are. That solves the problem. Now, T-shirts are out, and so there we have an IT nerd vest anagram, and that's Nathaniel's drawing of what real men can do with testing, and I like it because it's great, particularly his drawing of my hair and the shorts, and the slogan there, unit testing, and that's what I think of it. So, in summary, functional testing, a useful tool, and avoid the hype then about the unit testing. Customers want features, not tests. And we can debate these issues. There's a blog at testdrivenmadness.com. And finally, the Zen of testing. Just have a read of these. So, there are my contact details, and I think I better be going now. So. I can see from that you've had a visit from Irma. Sorry about that. But let's see how we can make something useful of this. So here are some debates that people might have. It isn't obvious that testing is a good idea. Often we say, oh, you know, testing, everyone should be testing, and we assume that people are actually doing testing. But as we saw from the show of hands at the beginning, people are on different stages of their journey towards test-driven development. So what I'd like you to do now, I know it's a bit crowded, but find somebody next to you, get together in groups of 2 or 3, introduce yourselves and choose one of these topics which you're going to argue about. Okay, so just make sure nobody's left out. Groups of 2 or 3. You might find it easier if you stand up and choose one of the topics, and you've got 3 minutes to do that. Let's everyone stand up. Okay. Okay. Right. Here's a good technique. Here's a good technique for getting quiet in a room. What I'll do, I put up my hand, and anybody sees me with my hand up, you put your hand up as well. Let's try it. Like that. And gradually the whole room puts their hand up, and then they're quiet without me having to shout. Okay, so what we do now, you've got a topic, right? Everyone chosen a topic in your little group that you're going to discuss. Doesn't matter if it's one that we've talked about today or another one. In your group, take sides. You know, doesn't matter whether you really believe what you're arguing. It's just to get the debate. It's an interesting point. What are the pros and cons of each point? So in your group, we've got 10, maybe 15 minutes to go into some detail about what are the main points about that. You know, why is it a good idea or a bad idea? How would you persuade other people to adopt your approach? And how do people argue against it? Okay, everybody clear with that? Right, next stage, appoint a spokesperson from your small group and find another small group to share your ideas, and the spokesperson take it in turns just to say what was the topic you were discussing, what were the main points for and what were the main points against. So find another small group, join together after you've appointed a spokesperson, one for each group. You've got 5 more minutes to share that.
Oh, you should turn it off again, the microphone, I think.
Okay, last exercise now. In your larger group, choose one of the topics that neither group has discussed, and you've got 10 more minutes. Split up, sort of half of you arguing for a point, half of you arguing against, see what conclusions you can come to, and then we'll sit down and just share a few thoughts between everybody. Okay, so 10 minutes, different topic. Right, thank you all for taking part so well. Please take your seats again for the last few minutes. So I'm not here to to answer any questions, but do we have a microphone to pass around? So really, just please, from your discussions, would anybody like to feedback any thoughts that they have, any questions to the rest of the audience?
Actually, in the second part, we discussed the unit test coverage should always be 100%. And assuming that you actually achieve that at some point, you can go from there either first writing new unit tests, which gets you over 100%, or you can start writing new code first, which gets you under 100%, which is both not what you want if you strive for that. So actually you will not do anything at all anymore, if that is your...
I'm not going to provide answers, you know. Is there... Too late.
So my team basically agreed that coding is art, and it doesn't matter what the internal state of the code is like as long as your software is beautiful, and it's all about humans, right? So, and basically it's about having a product that is so beautiful that you can sell it to a venture capital company and pocket the cash. Job done.
Yeah, I'm always wondering, what is 100% test coverage? Does it mean that each line of code is once executed, or that you have a test for each edge case? So if there's a function which acts on lists, do you have run it once through for an empty list, once for a list with one element, once for a list with two elements, once for a list with 100 elements? What is 100%?
Anyone like to comment on that?
I just want to say what documentation is unnecessary. This was our topic. And actually it's really hard to find a result in this discussion because there's tons of pros and cons and different workflows and situations happen to us in our experience. So the biggest problem, what is the balance and what to write in documentation? That's it. That's our basic question.
Yeah, a comment on the test coverage. Basically, well, what we more or less think is that if you write tests to get 100% of test coverage by using the current tools that check basically is that line get executed, it's a bad reason to write tests because you will actually miss most of the edge cases and your software might not work in the common case, even though all the line get executed because it will fail with an empty list. So yeah, that's a point on test coverage, is that saying the software works because it has 100% of test coverage with the existing tools, it's not true. It's a bad excuse. And on the topic of the documentation, we discussed a bit about it. Documentation is wonderful, except outdated documentation. Yeah, you have the point.
Yeah, again, coming back to the coverage, I think it's basically there are different coverage metrics. So you can say there is a line coverage, there is every path coverage, and some more sophisticated like conditions coverages where you, for example, verify that each, where you have branching, every variable that affects the branch, you reverse it and you see that the branch goes differently. And theoretically you could try to achieve 100% like kind of coverage of all possible execution paths, all possible ways, but your example with lists illustrates that this is not possible. But I mean, there are still several metrics And like if you just Google code coverage and look it on Wikipedia, there's quite a few different ways of how you can estimate it and kind of why this is important or that is better than this and so forth. And also we talked about, in the first little group, we talked about prototyping and spikes. And we actually, I was not sure, for example, and I think we both were not sure, but we agreed in the end that it makes sense usually to still have tests because like because it gives you a certain rhythm. Like this test-driven development rhythm, I think is very useful by itself, even regardless of the usefulness of the test. And having it is useful for prototyping. And also you do a lot of refactoring usually when prototyping, so it's useful to have tests.
Hi, yeah. I'd also like to agree with the prototyping person.
Since with the best will in the world, most prototypes make it to production. So if you have some tests that you can build inwards as you go along.
Right, well, that's our time is up, so thank you very much for coming and thank you for joining in, discussing about testing. Thanks.
Yeah, I'd also like to add that